Uh, Again, hello everyone. My name is Ivan. I'm a team lead for team who is building the customer service and order management app in a Boozt. Boozt, for the people who doesn't know it, maybe I don't know because of it's quite well known in Sweden. It's a Nordic department store for now. Before we was focused on the fashion, but now we're add more categories and we are more focused on the department store. A couple of numbers about the Boozt. So we have 3+ million active customers and quite good Trustpilot score. So because of the happy customers, it's actually the main value for the company. And we working on 14 markets and have 1,200 employees. Yeah. I'm from the platform team. PT, it's mean platform team. We are tech department in a Boozt. And a Boozt, it's we're always telling Boozt, it's not like a retail company or just some e-commerce company. Yeah, of course we are e-commerce, but we are tech company first. So because of the technology is everywhere in our company, and we are as a platform. It's our motto or slogan. We give the power to the people. Our solutions and systems helps the rest employees to do their best in a company and help us to be one of the biggest web shop in Nordic countries. Yes, and about the platform, I want to run this video from our Istio, his words about our culture and the rest of stuff.
The Boozt culture is fantastic. We have the values that we really believe in and have been living since day one. From platform point of view, we are even more lucky from the sense that we started a team from scratch. When I came in, there were nobody, so we actually could shape our own culture as we grew from nothing. We are born digital. We've been that since day one, and we are used to thinking in processes and automation, optimization and scalability, and being what we call an exponential company. So being able to be efficient with the people we have and the resources we have. We have always been, and we are still, extremely dynamic in our organization. Some actually call it an organism, not an organization. I think that's cool. So we are dynamic and we collaborate, but we are still fairly small in the way of thinking, and that's very much due to the startup mindset that we want to keep. An ideal platformer is dynamic, is okay with handling several things on the same time, is open and honest, both in giving feedback but also receiving feedback, and is willing to try something new because we are going new paths.
Yeah, something like that. So, and yeah, I want to add maybe a couple of words about the dynamic part. So dynamic, it's mean not like we are super active or something like that. It's like when you can adapt to the different situations on the market, in the company. Is there some crisis or new laws incoming or something like that? You need to react fast. And at the same time, as we are all of us working on the IT area, so everyone knows everything is going super fast. If you are just stop learning something new, you just will be outdated quite fast. So you need to learn something new every day. It's part of our life in platform. Yes. Now, this is this photo from our platform conference. It's an annual event. It's this year it was about 200, maybe even more, people joined, and we have 2 days, and there is yeah, no worries. There is where a lot of topics, and it was quite interesting. And I think maybe we can start to ask to come the people outside, because of it's quite common topic and really interesting. But we will share our experience on such places as well. I have some quiz or guessing part here to make it a little bit more interactive. So who will answer the number, or what? I will ask some questions, and you need to kind of guess some numbers or something like that. And who will be closest to the number can win the T-shirt, like I have. Maybe a little bit different colors I have, but it's actually a T-shirt from our company, what we Boozt own. It's an Enkel studio. It's quite good quality. So the first question: how many developers do we have in the platform, in the Boozt? So just try to guess. It's kind of 2,000? No? How much? 3,000. Oh, okay. In the total, we have 1,200 people in the company, so a little bit too much. Yeah, just guess. No, 25. Yeah, and garage and the small warehouse. Okay, no. Who more or less? Yeah. 1,800. 300. Okay, you're the closest one. It's actually a little bit less, 190. Reach me after the talk, and I will give you your present. Let me check the second question. Yep. How many locations we have in different countries, actually platform? So that those 190 developers not located not only in Malmo. How many locations do we have? Of 5. You're right. So you're the second winner. Contact me after the talk. Yes, we are on the 5 locations in the Malmo, in Aarhus, Copenhagen, Poznan, and Vilnius. So the Sweden, Denmark, Poland, and Lithuania. The next one is we have focusing on building the tailor-made systems, which we help our business to in the different angles, different areas. And normally, each our team is focusing on one tailor-made system. How many this tailor-made system we have? 20? Who? Less or more? No. What? No. More? The internal system. How many the systems we have? 42. Okay, 42. It's 40. Almost. Yes, actually, we have the teams, average team, the 5 people. So it's basically one team per system. Oops. Okay. Well, sorry. Yeah, we have a biggest the auto store installation in the world. So here is Angelholm in Sweden. It's a biggest installations. There is someone that's trying to beat us. A few years ago, there was some other auto store a little bit bigger than us, but we built it one more warehouse, and now it's and they connected, and now we are still the biggest one. Yeah, and for the last one. How our account in LinkedIn, what was the name of this account? And here is the answers on this slide. Just try to guess how it's coming. Platform. Boozt platform. No? How?
No, I think she just said.
What? What? Ah, okay, you're right. You will get the second one for your husband. Okay. Yes. Boozt Tech. It's you can easily find all information about the platform by this tech, Boozt Tech. Yes. Then we're moving forward to the presentation. Warm welcome to me. Our host is sick today, then I will kind of start my part. How we built our chatbot. Must-see case study. It's actually the Chat GPT recommend me to build the clickbait title for that presentation. Yeah. AI. About me. I'm a team lead, as I told before, and I have been in the Boozt more than 6 years and know a lot of about the platform culture. Feel free to ask me some question after the talk about. I can share my experience about that. I have 50 plus years of experience as a backend developer, and I really inspired by era of AI. I really like it, and I think in the closest future, everyone will work with it more or less every day. So yeah, and I'm an innovator. So not inventor, but innovator. So I'm kind of trying to implement the new stuff, new technologies, new ways of doing stuff in the Boozt, and in our area, especially. One of them, we're trying to adopt AI to our one of our channel to communicate with the customers. And actually, why we are building our solution? It's always the question. Yes, we are always trying to choose this way. So we are trying to buy the third-party solution first, test it out, how it's work, if it's work, and create some profit for us. And we see it's kind of something interesting and it's could work. And we start thinking at the same time to build our own. Why? There is some pros for it. It's we will have a full control, so you can make it more powerful, less powerful, have more function, less function, and etc. So you have a full control of this. It's in a competitive age. It's important because of if you just buy something, then your competitor just go to the market and buy the same. If they will see, okay, it's working, and you can build something else and be more competitive on the market. Quality, this is important. We actually checked the multiple companies which provide the such service and actually suggest for us. And it's important, it's hard to control this quality with some third-party solution. And these handshakes from the AI-generated images can say they're not perfect yet. So kind of we need equality. It's important. We cannot provide for example, customer service like this to our customers. Yes, and maintainability. So it's should be easy to maintain it. Add the new flows, remove our flows, be more dynamic, as our STO taught. So we need this maintainability and react faster and quicker and with the good quality. And of course, there is a cons. So it's take time to build, of course, and it's require some investments and resources. Couple of words about our customer service team. It's about 100 engines, and we getting the 50 case calls per month and 45 emails per month, and the 6,000 chats from the web and app per month. We plan actually to convert the calls to the chats more, because of it's more efficient for the customers, more efficient for us. We can implement some smart tools and automation for that. In total, it's 100K communications. It's one communication per every 6 seconds. Customers calling to our customer service, writing an email, chatting, and the rest of the stuff. We have multiple challenges on the building our chatbot. Of course, now it's there is no questions. Every chat solution for the customer service, they need to have some chatbot on the front line and do some stuff or collect the context. It's yeah, you always need to work with this, and we have it like I would say the old solution, our old solution. It's hard to maintain the flows, so there is a lot of flows and a lot of information, and it's hard to maintain because of the customer service own the whole text, how they communicate and interact with the customers. But we are kind of platform. We need to build for them those connections between different answers, text, questions, etc., etc. We have a multiple entry points, so it can be web and app. We have a multiple web shops, so it's not only Boozt. We have a Boostlet as well. So it's 2 web shops, and it's kind of we should think about it. There is a different answers for the customers for the same questions, so it's also creates some complications. Personalization as well, so it makes sense if customer logged in or customer in an app, and we know how and we know the name, customer name, and other information. We don't need to double ask it. So. And also about the personalization, we need to provide the answers which is like not like a robot is answering you, but it can be the different for the different questions, different answers, a little bit different. We have 15 languages, so it's also a challenge because of which works for one language probably not work for another, and it's kind of the complicated stuff. GDPR, protect the customer data. It's now coming more and more in our area, and it's really challenging. But we have this customer data protection mindset in the platform, so we're always thinking about it. And they have a lot of tools for keep to follow to all standards and laws what we have in the European Union. We have our own OMNI channels in interface. So we, for example, for that solution, we don't use their interface because we cannot work with this efficiently, and we kind of use their API, and we build our own solution for OMNI channels, and it's make customer service work really efficient. And when we start to find a solution, okay, we need to build our own bot. What we have should do? Okay, there was a well-known dialog flow, for example, or what we should use. And when we sit together and start thinking about it, we figure out actually we don't need something complicated because of it's actually the few steps what we need to provide. We should send a welcome message. We should detect customer question or intent, what the customer wants to do, and provide the answer based on our FAQ by using some AI system. And also we need to collect some information about the customer automatically, customer order or customer email. And should transfer the chat to the real agent if we cannot resolve it automatically, and if customer asks for it. So it's quite simple from the first glance, but when we goes to the reality, it's become more complicated. Our base idea. So it's we have some companies suggest us, okay, use our third-party solution. You can just need to provide the link to your FAQ, and we will teach our machine learning model, and it will create your chatbot. And we have in the platform actually data scientist team in Aarhus, and they actually doing that stuff. We're just, okay, why we not cannot do this? And they actually can do it, and they done it. So we okay, next slide. It's more. So how it's working? We decided to use the Chat GPT. It's not because of it's quite famous, but because of the Google Bart at that time wasn't available in the European Union because of the GDPR stuff. So now it's possible to use it, but on that time not. But we play it with the VPN stuff, and yeah. But still, we focus it on try it first on the Chat GPT. So how it's working in easy words. So we have our FAQ. It can be on multiple formats. We just use Chat GPT to create embeddings. It's numeric representation of the text. Maybe it's easy words. It's kind of the array of vectors or something like that. And the question, incoming question, we also convert to the embeddings, and it's help to find the most similar FAQ piece of text in FAQ, similar to that question. And with some chatbot instructions, it's prompt engineering. It's help us to fix those issues, like with the handshakes. So you can tune a little bit your model to be more accurate and precise. And together, it's generate the answer for the customer. Before everything, we have had a hackathon a few months ago. We want to build. It's an event. So in the platform, multiple teams they can combine together, or maybe it can be one team. They're doing the hackathon in the different formats. In our case, it was the format in a one day. We are building the proof of concept. So, and our task was to build, try to couple of technologies, the WebSocket, because if we plan to build our own widget, which will be connected to our system via the WebSocket. And at the same time, we tested OpenAI. It's Chat GPT. It's the same for our assistant. And yes, we've done it. Current solution, what we have, we call it actually our assistant Ksenia. It's our Viktor, lead developer, choose this name for some reason. Maybe it's his daughter name. No, okay. Yeah, Ksenia, customer service assistant. And on the front, and our website, we have still have the fresh chat widget. It's a little bit complicated task to build our own, but we plan to do it because we have to done it in on the app for our apps and for web version as well. So this widget is the message is coming to the CSI. CSI is connecting to the our assistant, which use the Chat GPT and Google machine learning to detect intention and other stuff. So it's a multiple pieces bind together. And what we plan to achieve later, it's build our own web widget, which will connect to interact with the assistant and CSI. CSI, it's our internal system. We call it for the our customer service and order management. So it will work like this. Yeah. Here's the slide about the WebSocket connection. So how it's will work, and yeah, from the widget, WebSocket will send the messages to connect to different parts of the CSI web widget and our assistant. The benefits what we plan to achieve by this solution, it's improved customer service experience, so it will be 24/7, so it's obvious stuff, and time and cost efficiency, it's more efficient than the real human, of course, and we will save time to our customer service agent. We don't want to replace them, we want to help them to do their work more efficient. And focus more on the really the cases where human need to be involved and get rid of routine, and then the customer service agent work become more interesting. This is really important. Scalability. It's easy to add more power to less power, so we can easily handle the 10 times more traffic, for example. Accuracy. So we will have more accurate answers by our own solution, and it will support the multi-languages. It's kind of on the market. It's for us, it's really important, but the all products on the market, what we have for party solution, it's kind of not all of them supported. Personalization. I told about it, so we plan to send not like a robot-like messages. It will be the human-like messages, natural responses, and integration is also super important for us. It should interact with our internal systems and get information from the customers, and yeah, it's really important to integrate it to our internal environment and systems. This picture is generated by AI, by the way. So it's what's is next in the Giger style. I like Giger style. So and we plan to build our web and web widget and app widget. We want to add the auto tests and validation for our model, because of it's important to provide the good quality, and without the testing and auto testing especially, it will not be possible. Automatic actions, so probably we will able to resolve some customer questions automatically. If they want to close the order or do an exchange, we can do the some of the steps automatically. We will test some other solution, Google Bart. It looks interesting for us, and also some other large language models. We will work on the personalization, and okay, I give a stage to the Viktor. He will more focus on the technical part, how we actually build it by Symfony and the PHP and the rest. Well, welcome.
Hi, my name is Viktor. I am working in Boozt and Play Factorio. That's everything you need to know about me, and I am working on our assistant. And I would like to start with the bad news, because AI is not a magic wand. We can't solve all our problems with AI. We can't make a great customer service with AI, and we can't just ask it to answer customers' questions. AI is only one little part of the whole system, and we need to control it. because we need to control that it answer correct questions. We need to control that personal information of our customers isn't safe. And assistant has to make much more than answer questions. It has to call and make several actions like order cancellation, customer personality verification, and etc. And it leads us to a pretty complex system, and we need to control this complexity. And it's very important because we need to make extension and modification of the system very easy, because it is maintained by several developers for a long time, and we need to change its behavior very often. And if we don't control our complexity, it will be hell. Why our system is so complex? We need to start from the very beginning, because conversation, it's a directed graph, a pretty big graph. This graph contains cycles, and cycles can contain other cycles, because our logic can be very complex. Also, some edges can be enabled or disabled, depends on context, on the income message, even depends on the time of day. The whole our conversation has a global context. We can access this context from any part of the system, and we can change this context from any part. Some parts of our graph has its own context. Every input message, income message, should be processed with some checks. For example, if our customer asks to switch it to the real agent, to the human, we have to do it. And keeping all these in mind, we also have remembered that this system will be changed constantly. It's pretty difficult. And who know the only one way to reduce the complexity of the system? It's remove some functionality from it. But we can't do it. We add this functionality. So we can or move functionality or complexity from one part of the system to another, or to hide it. Here we will try to hide this complexity. And how to do it? First, we can split our huge and complex graph to several smaller and transit between them. You can see that in these graphs, it's the same graph. But here we have a high-level graph with 6 vertices, and each vertex contains the subgraph. And the second point, we can add a middleware layer before our graphs, before our flow, to check all income messages and do or don't do something with them. And our system is built on Symfony, and Symfony provides very convenient tools. Its dependency injection container has an ability for after configuration, and we can use PHP attributes to avoid configuration files. State machines. State machine, it's one of implementations of graphs, and Symfony is good in this question too, because Symfony has a pretty good implementation of state machines, and it's very convenient for simple situations. This is a link for official documentation, but we wrote our own solution. I think everyone always wrote their own solutions. Why? There is Why we did it? Because first of all, we need to avoid configuration files, and Symfony state machines requires us to write a YAML file to describe its structure. And also, we need our transitions to decide by themselves what to do next. In Symfony's state machines, we can't do it. We have to make our transitions manually by calling the appropriate methods. So we create our own solution. We discussed it. We tried several variants, and after some time, we become to stack of state machines. It's a core of our engine. Three basics of this solution. Every subgraph is a separated state machine with its own configuration and state. Every transition can engender a new state machine and wait until it is completed. And the last, all state machines should be processed and completed in the reverse order of their creation. Here, this is our top level state machine. I will call it flow for the, it will be shorter. We start from this vertex and go here. Here our state machine in the stack. When we go here, we create a new state machine and put it on the top of our stack. And when the new income message come, it will go to the last state machine for its last transition. When this subgraph is completed, what we do? We remove this state machine from our stack, and the next income message will go to the previous state machine. It's our top level graph, and we will be able to make the next top level transition. It sounds strange, but it works. I will explain later in more details. The income message flow, high level view. We created engine which orchestrates all income messages, its flows, and we have the application layer, our business logic, and etc. What we did, we took complexity from this part and put it here. We covered all our engine with tests. We made sure that it works and forgot about it. So it's a black box. It works, and we can think only about our business logic, small parts of our business logic. So in this way, we moved complexity from here to here, but not decrease it. When a new income message is arrived, the engine will pass it to all middlewares by one. Every middleware has an access to the global conversation context. It can change it or it can read it. For example, we can, in all parts of the system, we need to know the language of our customer. Or maybe in one of the middlewares, we can recognize his language and save it to our context. When all middlewares is passed, the engine will pass the income message to our stack of flows. We will discuss this part later, but one point I have to admit that each transition has an access to the global conversation context, and also each transition has its own closed and private context. Transitions can call our business logic can call external services, our AI models, and yes. About this part. Yes, it's how we process income messages in our stack. It's a loop. the engine will go through these two steps again and again until we stop it. The engine, we take a new income message. The engine will take the last flow from the stack. It will take the last transition from this flow and apply it. Transition is just a class which implements the specific interface. In the transition, we made our stuff, call some business logic. We can read or send some messages, and this transition returns to the engine data transfer object with the result, with the further instructions. The engine handle this instruction and go it or terminates or go to the next iteration. What instructions can it be? Now we have only 5 of them. The transition can ask the engine to run the next transition from the same flow. We, for example, took customer's email and sent the verification code. And we ask the engine to go to the next transition to check the code from the customer. In this case, the engine complete this transition, so the next transition will be the next. The engine goes to the next iteration and process the next transition. Also, transition can ask the engine to add a new flow to the stack. It returns it in a result DTO, and a new stack goes here. And on the next iteration of the engine, the new flow will be the last, and it will be provided. And so only when the new flow will be finished, only after it, the engine will continue our current flow. Also, transition can complete the current flow. It means that the engine, first of all, it can pass the result of the whole flow to its parent, if the parent can handle it and implements the appropriate interface, and remove it from the stack. The transition can ask the engine to wait for the next income message. So in this way, the loop will be broke, and the program will be exit until the new income message. And also we can terminate the whole conversation in case of some problems, or if the customer asks about it. In this case, the engine will switch our customer to the real agent and exit. Yes? Sorry. It's a pretty complex system, but here we move a lot of complexity to it from our business logic, because now we can operate only with a small amount of code of our business logic. It's transitions or separate middlewares. We move complexity, and now we have to hide it. How to hide anything in programming? It's an encapsulation. We have to encapsulate all this logic in our engine. For it, we have 4 interfaces: middleware, flow, transition, and flow result handler. And 3 special PHP attributes. If I would like to create a new flow, for example, I have to create a class in any place in the application, implement this interface. All these interfaces contains only one simple method, and add the flow. The flow will require from me some metadata for this transition, for example. And that's all. Symfony's dependency injection container will, after configure it and put it to our engine will know about this new transition, flow, or middleware. Yes, this is a public interface of our engine. It's a point for extending. A little bit about, let's see some examples. It's not a real code, it's examples. I try to keep it simple, but it looks like it's very close to our real code. This is the first example. It's middleware, customer intention middleware, and for each income message we have check if the customer asks to speak with the real human, we have to switch him to the agent. If the customer wrote us something like, "Oh, thank you, robot, you saved my day," we have just to say, "Okay, have a good day," and complete the conversation as a solved or success. We use intention classifier. It's our model, neural network. So we specify several variants, and based on its decision, we terminate, switch to the agent, complete our conversation, and if the middleware returns false, it means that the engine will terminate the further processing. But if we return true, it will go further to the next middleware and to the stack of state machines. This is an example of flow. Here we can see several things. First of all, the flow attribute requires us to provide some metadata, for example, the name of this flow. And this is configuration and context classes for this specific flow. It's a email confirmation flow. I think you understand what it does. And we have configuration, the max attempt to type a wrong verification code. And when we send this code, we can store it in our context, and after it we can compare the code our customer typed and the code from the context. In general, the flow class, it's a bunch of boilerplate code. We need it only to group our transitions and store a little bit of constants. We have a trait to avoid all of this. This is an example of transition. It's a FAQ exploration flow, and when we understand that the customer just asked a question, we call our AI model and provide customer's question and take an answer and send it to our customer. The customer can ask another question to clarify his thing. And here we use a flow context because we store all users, customers' questions and all AI answers, because we need to pass the whole history, but not the whole history of the conversation from the very beginning, but only the history of this communication with the FAQ Explorer. And here we see also an example of using the global conversation context, because we specify the language for the model. And here is a result. We ask the engine to wait for next income message, because we send the answer and wait for another message from the customer. And the last example, it's another transition, and here I wanted to show you the different results. It's order cancellation flow. For example, our customer told us that he wanted to cancel his ongoing order. First of all, we have to check, are we sure that it's a real, that we are talking with this exact customer. If we don't sure, we create a new flow and return the process subflow result to the engine. Engine will take this flow and put it on the top of the stack, and on the next iteration the flow will go into this flow, and for example we will send code to the customer's email. But if we are sure, we can provide our customer a list of his ongoing orders and ask which of them would you like to cancel, and we return the process next transition result, and the engine will go to this result from the same flow. This system is pretty convenient because this is examples, but the real transitions pretty close by their size to these examples. They're simple, and if we have a new developer, for example, in the team, and it will be very easy to explain how to extend this system, how to modify. You have 4 interfaces, you have 3 PHP attributes. That's all. And that's all.